Hello everyone, I am R. Punitha Gauri, Assistant Professor of Computer Science and Engineering Department in Erode Singundar Engineering College. Now, I am going to take the topic on computer architecture and the subject. In this session, we are going to see the introduction part, functional units, basic operational concepts, bus structure, and performance measurement. So these are all the topic today I am going to take. Before starting into the introduction part of the computer architecture, we should know the course objective of the subject. What are the course objectives of this computer architecture subject? The first course objective is to understand the basic structure and operation of a digital computer. In order to use the computer as a computer science engineering student, we must know the parts of the computer and what are the functional units in the computer, how they are connected with each other, how they are operating in a digital computer. So all these things must be known. The second course objective is to understand the operation of the arithmetic unit. So the process doing all the arithmetic and logical operations. How the operations are performed must also be known. The third course objective is to know in detail about the concept of pipelining. In order to increase the performance of the processor, we are doing the concept called pipelining. So, how the pipelining are implemented in the processor is known. To know the hierarchical memory systems, including cache memory and virtual memory. Variety of memory systems are available in the market. We should know each one, and we should understand the importance of cache memory and virtual memory, and how can we improve the performance of the cache memory. Also, the last one is what are the input output devices are available and how they are communicating with each other, and how the input output device is connected to the processor by using the interface, input output interface. So these are all the course objectives of the computer architecture subject. After learning the subject, you should understand all these things. So for the first course objective is basic structure and operation of a digital computer. So in order to achieve this course objective, we should understand the introduction part, functional units, and operations of the digital computer. What is a computer? A computer is an electronic calculating machine that accepts the input, processes the information according to a list of internally stored instructions, and produces the resulting output information. So, computer contains the input devices. Computer has the input device and output device and the processor. In the input device, through the input device, we can get the input from the user, and we have to process the input, and we have to produce the output. So this is the main aim of a computer machine. So what is the functions performed by a computer are? It should accept the information from the user as an input, and this input is to be stored and processed. In order to process the information, we are having some instructions which is also stored in the computer. Based on the instructions given to the computer, it should process the input and provides the output. The result is provided as an output to the user. So, in order to do all these functions, accept, store, process, and providing the result, we are having 5 different functional units. input unit, output unit, which is combinedly called as input output unit, arithmetic and logical unit, control unit, and the main memory unit. Input unit, what should the input unit do means it should accept the input from the user and it should be converted to an electromagnetic information like binary information. So it should be converted, and this input is given to both memory and the processor. So the processor does all the processing on the input and produces the output. So the input unit which should accept the input from the user and it should be converted to a binary information. Next one, output unit. So this output unit gets the output from the processor and it should be viewed to the displayed to the outside world, displayed to the user. Okay. So the input devices are like keyboard, mouse, and joystick, and scanner, mic. All these things are considered as an input devices. The output devices are a monitor display, a LED screen, a printer, and a speaker. So all these things are considered as a output devices. The next one is a memory. What is the need of this memory? So we cannot do any operations without a memory system, because what is the operation to be performed is given by the instruction. These instructions must be stored in some place. So that should be a memory. So memory is a main part on all the 5 parts, 5 functional units. It should store the information, instructions, and the data. And the next one is arithmetic and logic unit. Arithmetic and logic unit, ALU performs all the desired operations on the input information and it should be given to the output unit. The result is to be given to the output unit. The ALU performs all the arithmetic and logical operations. The next one is the control unit. So this control unit is main important one because all other functional units are coordinated by the control unit by means of producing a control signals and timing signals. So the control unit produces the control signals and timing signals which is sent to the all other functional units, and by these signals this control unit control all other functional units. So these are all the main parts and functional units of a computer. Next, what is instruction? Instructions are commands. Instructions are commands which is given to the computer. So it transfers the information within a computer from memory to the ILU, for example. All these instructions are stored in a memory, as I told already. All the instructions are stored in a memory. In order to do any operation on the ALU, the instruction must be get it from the memory, because the ALU doesn't know what is to be done with the input data. So what operation we have to perform on the input data is given by the instructions. So based on the instructions given to the ALU performs the operations on the input data. And it also transfers the information between the computer and input output devices, like from keyboard to computer, computer to printer. So all these things are performed and perform arithmetic and logical operations. For example, addition of two numbers, perform logical AND. So all these logical and arithmetic operations are performed by the ALU based on the instructions. So the instruction specifies the three different commands. First one, transfer information within a computer, and transfer of information between the computer and the input output device, and perform arithmetic and logical operations. So all these things can be performed and done based on the instructions. A sequence of instructions to perform a specific task is called as a program, and the program must be stored in the memory. A sequence of instructions in order to perform a specific task is called a program. The processor fetches instructions that make up a program from memory and performs the operation stated in those instructions. So all these instructions must be operate on something that is called data. Okay. So all the given instructions are to be operated on some data. Data are the operands upon which the instructions can operate. A data could be a number or encoded characters, and it should be a digital information. So computer uses the data that is encoded as a string of binary digits. We will shortly call it as a bit. So this binary digit is simply we will call it as a bit. And we are going to see some in detailed depth of input unit. The binary information must be presented to a computer in a specific format. This task is performed by the input unit. So the user need to feed some data to the computer through the input unit, and this input unit gets the input and it should be transferred either to the compute memory or processor. For this, the interfaces with the input devices, it should be done because the input device should be connected with the computer through some interfaces, and it should accept the binary information and presents the binary information to the computer, transfers this information either to the memory or the processor. For example, if we are feeding some data to the input unit, for example, some files I have to be stored in my memory. Means this can be done by, we have to give the file to the input unit by input unit, and it should be stored in a memory, means it should be given to the memory system, or I have to perform some operation, means this input information should be given to the processor. So either one of which, either given to the memory or processor, should be done by the computer. Next one, memory unit. Memory unit stores instructions and data. Right? So it should store some instructions and data. So instructions or commands, and like data or operands or some encoded information like that. So the data is always represented in a bit format. To store the data, memory unit stores the bits. So in order to store the data, the memory unit stores in a bit format. Processor reads the instructions and reads data from the memory or writes data to the memory during the execution of a program. So while performing any process or while performing any operation, the processor reads the instruction. Based on the instruction, it will read the data from the memory or writes the data to the memory. Instructions and data could be fetched one bit at a time, but in practice, in theory, we are seeing like it, we have to process one bit at a time, but in practice, it is not possible. So, we have to do the parallel processing. So, a group of bits are fetched at a time. So, a group of bits are fetched at a time. So, this group of bits, the size of the bits can be termed as a word. So, for each computer, this word length may be a differ based on the processor design, which processor we are using. We can say it as a 32-bit is a word, or for some computer systems, it may be a 64-bit or 128-bit like that. So for every computer, this word length may be vary. This based on this word only, we are going to install our operating systems. We can call it as a 32-bit operating system, 64-bit operating system, 128 operating system, right? So this bit, 32-bit, 64-bit, 128-bit. This is the word length of the particular processor. If you are using a 32-bit processor, you have to install the 32-bit operating system. If your processor process the 128 bits at a time, means you have to use the 128-bit operating system, 64-bit operating system like that. So the group of bits processed at a time is called as a word. This word length may be vary for each computer. So in order to read or write data from or to the memory, the memory system stores all the information, and all this information on data could be accessed through the address. So for each location in the memory system, we are having some address to specify this location. So based on this address only, we are going to access the information. Address is associated with each word location. So processor doesn't know the data, but it should know the address where the data is residing over in the memory. So based on this address only, memory address only, the processor going to access all the data. Either they may be a read operation or write operation. So based on this memory address only, we are going to access the data. In order to access any word location in a short and fixed amount of time based on the address is needed. So for that, we are using the random access memory system, RAM memory, which provides fixed access time independent of the location of the word. If we are going with the sequential access, means in order to access the particular word in a memory, the process should start from the starting address and it have to find the specified address. It takes too much of time and it is not possible in the real world. So the random access memory system is introduced, which is used to access the word location. The particular address is given, it should directly access to the particular address without need to access the other address. So it directly access the given address. Access time is known as memory access time. So in order to access one word in a computer is the time, we will call it as a term by memory access time. It is the time needed to access one word in a memory system is called as memory access time. Memory and processor have to communicate with each other in order to read or write from of information. Absolutely. So the processor and the memory should have to communicate in order to fetch the information or write the information or decode information. So for all any operation, both these things, memory and processor, should be communicate with each other. But most of the time will be spent on this communication time rather than accessing the data. So the communication time should be reduced by using the RAM. So in order to achieve the high performance and also reduce the communication time lesser, we are using the concept called cache memory. So this will be discussed later. So cache is a small temporary memory. It is also a part of a RAM. So this cache memory is used to store the repeated instructions. So repeatedly executing instructions and data will be stored in a cache so that the processor can easily get it from the cache, not going all through the RAM, main memory. Okay. So cache is a fastest but smallest memory, whereas the main memory is the largest one, but it processes the data in a very slow. So the memory system can be divided into two types: primary memory or secondary memory. Okay, this primary memory is also called as main memory. So primary memory is the main memory system, which is most important in the memory system because all the instructions executed in the processor is accessed from the main memory. So both the instructions and data should be stored in the primary memory so that the processor can get it from the primary memory. So the processor will always access the primary memory, not the secondary memory. Okay. So this primary memory consists of RAM units, and this RAM units is divided a small part called a cache memory. So the cache memory is the fastest one but smallest unit, but this main memory or primary memory is the slowest one, but we can store the large amount of data like our hard disk. Okay. So primary storage is insufficient to store the large amount of data and programs. So in order to store huge volume of data, the primary memory alone is not enough. So we are going for the secondary memory. So in order to store huge volume of data, the primary memory is not enough in order to store that huge amount of data. If we store, then the process of accessing the data will be very slow. So in order to store the huge volume of data, we are using the other device called secondary storage devices. This secondary storage devices may be a magnetic disk or CDs, DVDs. So all these things are considered as a secondary devices. And the next one is ALU, arithmetic and logic unit. Operations are executed in the arithmetic and logic unit. ALU performs all the arithmetic operations like addition, subtraction, etc. And logical operation means we are doing the comparison of numbers. So in order to execute an instruction, we should need two things. First one is the operand and the instruction. So the instructions tells the ALU what is the operation to be performed on the data. So the operands must be given to the ALU and the instruction is also given to the ALU. So operands are always stored in a memory. Sometimes it should be stored in a registers also. The registers are also a small temporary memory, very small temporary memory. It is used to store the some data. The access time of general purpose registers, this GPRCs, are faster than accessing the cache. So, compared to RAM, cache is faster. So, compared to cache, registers are very much faster. So registers are very small unit. In order to do some operations on the ALU, we can store the operands in the general purpose register so that the ALU can get it from the registers itself. So the memory access time will be reduced as much as possible. And the results of the operations also stored back in the memory or retained in the processor for the immediate use. Either the results should be given to the memory or registers itself. Next one is the output unit. The computers represent information in a specific binary form, but this binary form cannot be understood by the programmer or user or the outside world. So this output unit converts the binary information to a user understand format and accepts the processed results provided by the computer in a specific binary form and convert this binary information into a form which is understood by the output unit. Okay, so the output unit gets the information either from the memory or the processor and it should be displayed to the outside world. Next one is the control unit. So operations of a computer can be summarized as accepts, stores, process and provides a result. So accepts information from the input unit, stores the information in a memory and processes the information in ALU and provides the results to the output unit. So these are the four other functional units than control unit. So other than control unit, we are having four different units: input, memory, ALU and output. So these are all the main operations of each unit, right? So these operations of input unit, memory, ALU and output unit are coordinated by the control unit. So the instructions control what operations to be takes place on the what data. So the operations may be data transfer or doing some processing. Control unit generates the timing signals which determine when a particular operation should take place. So all these four units must be coordinated by the control unit by generating the timing signals. By this timing signal only, the particular operation should start and end. So all these functional units are connected in a way by using the bus. So input unit, output unit, memory and processor. So all these four functional units are connected by a cable called bus. A bus may be a line or a cable in order to connect two devices. And this bus can be used for the communication purpose also. So in order to transfer a data from one place to another place, for example, one functional unit to other functional unit, this can be done by the bus. So bus carries the data from one place to another place. The bus contains a group of wires. So each wire in the bus can transfer one bit at a time. So So the collection bus contains the group of or bunch of wires. Each wire can carry one bit at a time. For example, if your bus is capable of transferring 32 bits at a time, and inside the bus there must be a 32 wires, bunch of wires. Okay. So this number of wires in a bus is equal to the word length of a computer, right? So already we have seen the what is word length, what is word, and what is word length. So word length is the amount of bits, the number of bits which could be processed at a time by the processor. So the processor's word length must be equal to the number of wires in a bus. So both should be coordinated. In memory system, we are having the main memory and the processor. So main memory is a primary memory which is connected to the processor by a bus, and the cache memory is always placed in a processor so that the processor can get the information easily from the cache memory. So it need not to go to the main memory and ask some information. So if it is available in the cache, it can get it from easily so that we can reduce the memory access time. So this cache memory is placed in the processor itself. This cache memory stores the repeated and frequently used instructions. If the processor needs some instruction, first it should look into the cache memory. If it is available in the cache, then it can get it from the cache memory itself. If it is not available in the cache memory, then the processor should approach the main memory. So this is the way how the memory and processor is communicating. So if the processor needs any information, first it should look into the cache memory. If it is available, it can take it from the cache memory. If it is not available, then it will approach the main memory. So this information is passed through the bus. That's why we are saying that cache is the fastest memory, because the cache memory is inside the processor. The access time can be much more reduced in rather than accessing the main memory. Since the main memory contains large volume of data than cache memory, it is not possible to search in a big place. It will take some time in the main memory. But cache is a very small amount of memory, and also it is available in very close to the processor. Since it is a small memory, small size memory, the particular word can be accessed is can be searched in a very small amount of time. Main memory is a very big one compared to the cache memory. So in order to access a particular word, it takes some time. So that's why we are saying that main memory is the slowest one and cache memory is the fastest one. So this is the way how the functional units and components of a computer are connected. There should be a main memory and memory system input output units. So these things can be connected by a system bus within the processor. So memory and input unit is connected to the processor by means of the system bus. So within the processor, we are having different terms like MAR, MDR, PC, IR, some general purpose registers, control unit, and arithmetic and logical unit. So all these combined pack is within the processor. So within the processor, we are having different registers like MAR, MDR registers, and also we are having the program counter, PC, and control unit and ALU. So basic operations of computer. So in order to do any operation, what is the steps to be followed by the processor in order to do some operation is discussed here. First thing, we are having a different n general purpose registers or not here, right? Or not R1 up to Rn minus 1. So these are all the general purpose registers used in the processors. We can have n number of registers. Okay. So it is used to store some operand values. And the next one is this memory address and memory address register and memory data registers. So these are all the two different registers in order to access some information. So this memory address register, this MAR always contains the address of the data, right? If the processor needs any data from the memory, this particular address is given to the MAR, and this MAR carries the address and it should be given over to the memory in order to access the particular word. After accessing the word, if it is a read operation, this particular data is given to the MDR. So memory data register, this will carry the data. So note it down as the MAR is a unidirectional one. So it will always get the address and this address is passed over to the memory. So that's the role of MAR. It always contains only the address, not the data. And this MDR is a bidirectional one. So if the processor is doing a read operation, then the particular address is given to the MAR and this address is passed over to the memory, and after getting the data it is fetched into the MDR bus. So this MDR bus carries the particular information and it should be given to the processor in order to do some process. This is how the read operation takes place. But if it is a write operation, we have to write or update some data in the memory, means both the address and data which is to be written into memory. So the address and the data, both these things should be given to the memory. In this particular address, this particular data should be written. So this is how the memory operation takes place. So mainly the MAR is a unidirectional, MDR is a bidirectional. It gets the data in read operation and it takes the data from the ALU or memory unit or processor in order to do a write operation. So what is PC here means? So PC is a program counter. Program counter means it will store what is the address of the next instruction to be executed. It will keep tracks on the instructions which are executing in a way. So it will store the address of the next instruction which is to be performed by the processor. So it will, so that this MAR can easily get it from the program counter. And what is IR means? IR store the decoded instructions which is currently being executed by the processor. The current operation executing in the ALU is stored in the IR, and the address of the next instruction to be as performed is stored in the PC. PC contains the address, whereas IR contains the decoded instruction. So this is how the operation, basic operation, read and write operation can be performed in a computer. This is what explained in these steps. So registers are fast standalone storage locations that could hold data temporarily. Multiple registers are needed to facilitate the operation of the CPU. So the first one here is MAR and MDR, memory address register, memory data register. MAR always holds the address, MDR always holds the data. So IR holds the instruction that is currently being executed. So the current operation executed is stored in the IR. Program counter points to the next instruction that is to be fetched from the memory. So what is the next instructions to be operated is stored in the program counter. First, the program counter always holds the address of the next instruction. If one instruction completes, the next instruction to be executed is stored in the PC, which means this PC holds the address of the next instructions to be executed. This PC, content of PC, is given to the MAR so that this MAR carries the address of the next instruction, and this MAR contents is passed to the address bus to select a memory location. So this PC contains the address of next instruction, which is given to the MAR. MAR passes this address into a memory location, and the read signal, control signal, is generated. By alerting this signal, the memory knows that there should be a read operation and this address is available in the address bus. So the memory gets the address from the address bus and make a read operation, and the particular data reads instruction present in the memory and loaded into the MDR, and the particular instruction must be loaded into the memory MDR, memory data register, and this MDR places the contents in the IR in order to decode the instruction, and after decoding we should know what is the operation to be performed. So if it is a arithmetic and logical operations, then this instruction is given to the ALU. Okay, so this is the way how the operations are performed. So after doing the this read operation from the memory, the PC is incremented to the next level of address. So next address, the PC automatically, after the particular instruction is loaded into the IR, then PC automatically pointed to the next instruction. If the data required for the operation is available in register, so now the instruction is ready, which is available in the instruction register, and the data needed for the particular operation is available in the register, then it performs the operation. If it is not available in the register, then it should be in the memory. So we have to get the operand values or data from the memory. For that, the address should be given to the MAR. Again, the contents of the MAR placed onto the address bus, and the read signal is alerted. So after accessing the data in the memory, that particular data is given to the MDR. This MDR transfers the data to the ALU, and after getting all the operand values and data, the ALU performs the particular operation, and the result is to be stored either to the register or to the memory. So if it is stored to the register, means it is directly given to the register, and if it is to be stored in the memory, means again the write operation will be executed. So where the result to be stored, the address is given to the MAR and the data is given to the MDR, and the write signal is alerted. After getting this alert signal, write alert signal, the memory gets the data from MDR and gets the address from the address bus. So in that address, this memory places the result. So this is how a basic operation will be performed by the processor. So While doing some operation, some devices may need some services, which is most important one. Okay, some devices, normal execution of the programs may be interrupted if some devices require some urgent servicing. So to deal with this situation immediately, the normal execution of the current program must be interrupted, which means current state of the execution is stored in some place, and we have to provide a service to the device, particular device, which is raised an interrupt signal. And after completing the service, interrupt service, and it should resume to the previous one, the normal execution of the program, by accessing the already stored information. So the procedure of interrupt operation is the device raises an interrupt signal which needs some urgent service. So the processor provides the requested service by executing an appropriate interrupt service routine, which is called as ISR. The state of the processor is first stable. So already the processor is executing some instruction, some operation. So the current execution program status is saved in somewhere, and the ISR is executed. So normally the contents of the PC, the general purpose registers, and the some control information, or all these things needed for the used for the previous operation is stored in the memory, and should start servicing to the interruption. And after completing the ISR, the state of the processor is restored so that the interrupted program may continue. There are 4 different classes of interrupts: program, timer, input output, and hardware failure. And the next one topic is bus structures. A group of lines that serves as a connecting path for several devices is called a bus. So bus is a group of line which is used to connect several devices, and it always carries some data. In addition to the lines that carry the data, the bus must have lines for address and control purpose. So the bus should carry address and also control signals. The simplest way to interconnect functional unit is use the single bus as shown in the below figure. So here we are having only a single bus which is connected via to the additional bus for connecting all these functional units to the processor. If you are having the multiple bus, then we can get the increased performance, but this is not a easy way to have a multiple bus. So, which is very costlier, and also it is not in practice also. Always we are having a single bus architecture. So in single bus structure, the devices are connected to a bus vary widely in the speed of operations, right? So in single bus architecture, all the devices are connected. For example, a keyboard, a printer, and a processor, and a memory control unit. So all these devices are connected via the single bus. So any one of the device is very slower in operating the information, in processing the information, but some of the devices will be very fast. For example, memory is always processed in a very fast because RAM is there and cache is also there. So the memory operations can be performed which is considerably fast than other devices, than input devices and output devices. In order to efficient the transfer mechanism, we need some other register, that is buffer registers we are used to here. With this buffer registers, the devices hold the information during the transfers. And another approach is to use two-bus structure and an additional transfer mechanism. By this two-bus structure, we can achieve the high performance, but it is not necessary. So we are going with the buffer registers. So each device, input unit, output unit, so all these devices having some buffer registers in order to store the information during the transfers. The next one is the software. In order for the user to enter and run an application program, the computer must already contains some system software in its memory. So the system software may be a operating system, which is a collection of programs that are executed as needed to perform functions such as receiving and interrupting user commands, running standard application programs such as word processors, GURMS, etc., and managing the storage and retrieval of files in secondary storage devices, controlling input-output units to receive input information and produces the output results. So operating system is a main program, which is a large program or actually a collection of routines that is used to control the sharing of and interaction among various computer units as they perform application programs. So in order to use application programs, we must need some system software. So application softwares are accessed and used only through the system software. So system software is a very much important one, basically operating system. So which is a very important one. Then next one is the last topic is the performance. So the speed with which a computer executes a program is affected by the design of its hardware and its machine language instructions. So we can evaluate the performance of our two different computer systems by measuring the performance of each one based on the design of its hardware and the instructions which is used in the processor based on this hardware and the instructions we can measure the performance. For the best performance, the following factors must be considered. The first one is the compiler, which converts the high-level language to a low-level language, and the instructions which are used in the processor and the hardware design. So based on these three things, the performance may be affected. Basic performance metrics. So what are the metrics used in order to compare the performance of different computers? First one is the response time, the time between the start and the completion of a task in time units, which means in order to complete a particular task, it takes some time. So this time is called as response time. The start and completion of the task is measured with the response time. Throughput, the total amount of tasks done in a given time period. So number of tasks per unit of time. For example, here is a car assembly factory which produces the car in 4 hours. So in order to produce a single car, it takes 4 hours. So this is the response time. But in a day, in an hour, it can produce 6 cars. So based on the manpower and also the availability of the parts, it can produce 6 cars per annum. This is called a throughput. So the number of has completed in given unit time is termed as a throughput, and the time between the start and completion of a task is termed as a response time. So, if we want to measure the performance of a machine X, we have to find the execution time of X. The inverse of execution time is called as a performance. If we are having two systems X and Y, and we have to measure the performance, means, for example, if X is n times faster than Y, means the performance of X is calculated and the performance of Y is calculated, and the ratio is given as a n times. For example, if your machine runs a program in 20 seconds, that is, execution time of machine A is 20 seconds, the execution time of B is 25 seconds. So, we can simply say that the performance of machine A is 1 by 20 and the performance of B is 1 by 25. So, which one is the first one? Absolutely the A, because it has only a less execution time than the machine B. So, A is faster one by means of this 20 seconds. So, B executes the same program in 25 seconds. It takes a high execution time, but A completes the same program in 20 seconds. So, A is a faster one. So, we are having another term in order to measure the performance is clock. The process circuits are controlled by timing signals called a clock. The clock defines the regular time intervals called clock cycles. So, clock is a timing signal and the clock cycles are regular time intervals. To execute a machine instruction, the processor divides the action to be performed into a sequence of basic steps such that each step can be completed in one clock cycle. So, if we are having some instruction, so the whole instruction cannot be executed in a given one clock cycle. So the big instruction, the complex instruction is divided into some sequence of basic steps. So each of these basic steps to be executed in the one clock cycle, so that we can execute the whole instruction in a number of basic steps which we are divided. Okay. So length of the V of one clock cycle is inverse of the clock rate. So here we are having the clock rate as R, and R can be measured by the inverse of P. P is here length of one clock cycle. So here is the basic performance equation: N into S divided by R. T is the processor time required to execute a program. So T is the time required to execute a program. N is the number of instructions in the program, and S is the average number of basic steps needed to execute one machine instructions. So N into S divided by R. R is the clock rate here. So this is the basic performance equation. So, how we are going to improve the performance? By means of using two concepts called pipelining and superscalar operation. So, pipelining is overlapping the execution of successive instructions. So, at a time, two or more instructions will be executed without interrupting with each other. And the next one is superscalar. So different instructions are concurrently executed with multiple instruction pipelines. So this means that multiple functional units are created. Okay, so these are all the two different methods in order to improve the performance of a computer system, and also we should improve the clock rate. That thus R should be increased, so that look into this equation. So if we increase the R value, then automatically the execution time of the processor T is reduced. So T is the inverse of R, right? So if we increase the clock rate R, we can get the better performance. So that here we are saying that clock rate should be improved. So, and also if we improve the technology of ICs used in the processor, so integrated circuits used in the processors technology must be improved, which also reduces the time needed to complete a basic step. So these are all the ways we can improve the performance of a computer system. And also we can reduce if it is possible, we can reduce the clock period P, and we can reduce the number of basic steps to execute. So this can be done by using the different computer sets called reduced instruction set computers and complex instruction set computers. So reduced instruction set computers contains the very basic steps, and but it contains the large value of n. So s is small, n is large, but in complex instruction set computer s is very large and n should be the number of instruction is reduced. So these are the two different set computers which is used to increase the performance, improve the performance. So that's all about the session. Thank you.